Hello friends, as part of this discussion, we'll be covering parallel processing concept in Python. We'll try to understand what is multi-threading and multiprocessing concepts in Python with some examples. So let us see what is parallel processing. So parallel processing is the ability to execute multiple tasks simultaneously to improve performance. And why it is important? It utilizes multi-core processors efficiently. Nowadays, in most of our systems or in computers, we have multi-core processors. So we should efficiently use those. We can utilize based on our need. So we can efficiently use all these processors, multi-core processors, using parallel processing. And how it helps, it reduces execution time for compute intensive task. So if our program is compute intensive, we can utilize parallel processing to reduce the execution time. And also it improves responsiveness in applications. Our application also becomes more responsive. It doesn't become slow if we apply this parallel processing concept. So now we'll see how many types of parallel processing are there in Python. So there are different ways to do parallel processing in Python. One of the technique is multi-threading. It uses multiple threads within a single process to run task concurrently. And then we have multiprocessing. So in this case, it uses multiple processes and also it uses its own memory space and run task in parallel. So basically multiple processes in this case uses its own memory. So process uses its own memory, but in case of threads, it shares the memory. And another technique is asynchronous processing. So we can also run async processes. So it uses basically event loops and coroutines to handle this task concurrently. So we'll see with some examples. So moving ahead, why multi-threading is required when we should use multi-threading. So suppose we are using IO bound tasks in our applications or in our programs. So like reading from multiple files, or we are calling APIs. So while reading files, making API calls, we can use multi-threading. So basically IO bound tasks we can do using multi-threading. Now let us discuss about multiprocessing. When to use multiprocessing? So if the task is CPU bound task, so we can use multiprocessing in case we have various, nowadays it's available, as I mentioned earlier, all the systems have now multiprocessors, so we can use multiprocessing. Suppose our program is heavily using mathematical computations, doing some data processing work. So in that case, multiprocessing would be suitable. It uses multiple processors, and this process is basically created to run in multiple processors available in our system, and all these processes use its own memory, as I mentioned earlier. So these are the two different scenarios where to use multi-threading and when to use multiprocessing. So accordingly, we can use IO bound tasks. Basically, we can take help from multi-threading aspects, and then for CPU compute related or compute heavy applications, we can use multiprocessing in that case. So basic difference already we have discussed. So in case of multi-threading, memory is shared. In case of okay, so suitable for IO bound tasks, and multiprocessing, as we mentioned, CPU bound task. Execution, multi-threading, it runs concurrently, and multiprocessing in parallel it runs. So we'll come to that. We'll see in details how things works. We have some Python code also to explain. And so GIL affected, so it's global interpreter lock. It's a concept in Python. We'll also see in detail what is GIL. So it affects multi-threading, basically affects GIL basically, and multiprocessing, GIL is not affected in case of multiprocessing. So before moving ahead, let us see some simple examples to see how multi-threading works in Python. So let's say in this case we are showing multi-threading in Python. So we are importing this library threading, and then that's how we can create threads. So we have a function over here. This function basically using this thread. So we have created a thread here, and in that thread we are running this function. So this function is running in a separate thread. That's how we start. And if you see here, this code will run. So that's how it will generate the output by running a separate thread. So in Jupyter Notebook, sometimes you will find that the output is not properly visible, or code gives some kind of errors. So you can directly use Python command prompt to see the execution of this. I'll show you later how things works. So Jupyter has some limitations to dealing with all this, because the output thread and processes, it's complicates in running in Jupyter, but I'll show you through command prompt basically how Python executes all this. So we'll go there and see. If I kill this interrupt, let's say restart, and then let's try to execute. It should work. It should not take that much time. Yeah, it's now running. So that's how using a thread we are executing this function. Now let's look at multiprocessing in Python. So this is a library we are importing. If you see how we create the process, so same function, by creating a process, so we can execute this function. Let's try to run this. So the output is right now, it's not visible, but if I show you Control C, if I go to the command, yeah, so here it works like this. If I run execute, so hello from process. So if you see this example through parallel process came out. So using this process object, we can run this function. So inside a separate process, this function would be executed, and these results were printed. And this example basically demonstrate GIL impact. So in multi-threading, in case of multi-threading, it has some dependency on global interpreter lock. So we'll see that how that impacts. So global interpreter lock, or GIL, is a mechanism in C Python that allows only one thread to execute Python bytecode at a time. So it has some dependency. So thread is dependent on GIL. So at a time, only one thread can execute. And implication wise, it limits true parallelism in multi-threading for CPU bound task. So in that case, we can use multiprocessing. Multi-threading is basically suited for IO bound task, as we discussed. Basically, it's due to GIL dependency. So GIL has some restrictions. At a time, only one thread can execute. And in that case, multiprocessing will help you, because it avoids GIL dependency, since each process has its own memory space. Okay, so this code you can play out with this and try to understand that how long it takes to execute these different threads. Then we have some examples using thread pool. We can manage the threads efficiently. This code you can run through Python. In Windows, we have some limitations, like I wouldn't say limitations, but in Jupyter Notebook, if we run this, output may not be quickly visible. It may not come out, but in command prompt you can run and check through Python shell. You can check this code. Definitely it will run. And then similarly, using process pool executor, we can efficiently handle multiple processes. So you can see we can play with this code. I have mentioned some limitations in running in Jupyter Notebook, especially in Windows as well. So you can check in your Python shell running this code and how it works. And then evaluation of these codes, like how we can do the evaluation performance wise. We can evaluate using this code. You can check how efficient these code are compared to serial execution. So serial versus parallel processing comparison you can do. You can check the timings, execution time using this code. So do check out using Python command prompt or shell. I have tried, let me show you one example how you can do. Let me find the command prompt. Yeah, so here is my command prompt. So I have gone to that location. I can show you that code, and then process time evaluation. So I'm running this code. So time is taking. So process time evaluation, if I show you the file, this is the example process time evaluation. And in our code also, if you see, yeah, this example is present here, process time evaluation. Yeah, execution time 0.43. And this code, okay, so you're seeing multiprocessing here. Let us check the file where we have our code related to, yeah, multiprocessing. So execution time is this, multiprocessing. Yeah, yeah. So this is the one which we saw through command prompt. We have ran it and checked the time, how much it is taking. So you can play around with this code. Now going back to this, okay, we discussed about Jill. Now we'll see best practices for parallel processing. So already we discussed use multiprocessing for CPU intensive task, use multi-threading IO bound task, avoid unnecessary thread synchronization to prevent bottlenecks. Yeah, you should take care of this. And using this features, we can do better resource management. In the code you will see we have some examples like this, how you can do, how can you manage all those threads in a better way. So follow those. In summary, we can say that parallel processing improves efficiency and speed. Python provides different way to do this. One concept is multiprocessing, another is through threads, and also we can have concurrent futures modules, which helps us to do thread related stuffs. And choosing right method uh, depends on the nature of the task you are basically intend to do. And you need to also understand the GIL, global interpreter lock concepts in Python, how it impacts in thread execution, why threads are dependent on that. And benchmarking and profiling will help you to understand the performance better and do the performance tuning as well. So we have also provided example code where you can see how we can do that. So refer to our links. You can play with the code in Git repo. Okay, so that's it for today. Thank you.